In the world of cybersecurity, the most dangerous attacks don't come from across the ocean. They come from the person sitting next to you on the same Wi-Fi. Imagine being able to invisibly step between a user and the internet, to see their data, or simply cut their connection with a single command. This is ARP poisoning. Look at this layout. Usually, the user and the router talk directly to each other. It's a closed loop of trust. But that trust is about to be exploited. The attacker at the top sends fake ARP packets to both sides. He tricks the user into thinking he is the router, and tricks the router into thinking he is the user. Now, look at the red arrows. All traffic is being redirected through the attacker's machine. He is now the man in the middle, seeing everything you do. By simply disabling port forwarding, the attacker stops the data from reaching the internet. The user is still connected to Wi-Fi, but their internet is dead. This is how a kill switch works. Now that we understand the theory, let's see it in action. First, we need to find our target on the network. I'm going to use nmap with the command nmap 192.168.1.0/24. This scans every possible address on my local subnet. Nmap is coming back with several active devices. I'm looking for my Windows 10 lab machine. Based on the MAC address and the open ports, I found it. 192.168.1.45. This is our target for today's demonstration. Switching over to our victim machine, which is a standard Windows 10 build. First, I'll open the command prompt and run ipconfig. Right here, you can see the IPv4 address is exactly what nmap found, 192.168.1.45, and our default gateway is 192.168.1.1. Now, let's verify the connection. I'll open a browser and head over to YouTube. As you can see, the page loads instantly, the thumbnails are popping up, and the connection is fast and stable. Everything is working exactly as it should be. Now, before we send the ARP packets, we have to decide, do we want to spy on the data, or kill it? This comes down to a deep system setting in the Linux kernel called IP forwarding. This setting tells Kali whether to pass the victim's data to the router, or drop it on the floor. I'm running the command, echo 0 vertical bar sudo t, proc, sys and net, IPv4, IP_forward. By setting this value to 0, I am telling my Kali machine, do not forward any packets. My computer will receive the Windows 10 data, but it won't send it to the internet. It becomes a dead end.
Now we launch the attack. In the first terminal we run sudo Arp Spoof ith0t192.168.1.45.192.168.1.1. This tells the Windows machine at point 45 that we are the gateway. It stops sending data to the router and starts sending it to our Kali machine. But we need to complete the circle. In the second terminal we run sudo Arp Spoof ith0t192.168.1.1192.168.1.45. Now we are tricking the router into thinking we are the Windows machine. We are now perfectly positioned in the middle. With both terminals running, every single packet of data must pass through us. And since we disabled forwarding earlier, this traffic has nowhere to go. Let's head over to the Windows machine for the final proof. Now for the moment of truth. We are back on the Windows 10 machine. I'll try to open my YouTube channel and look at that. The loading icon just spins. No thumbnails, no video, no data. The kill switch is holding firm. Let's try a different site. I'll head over to Google. Usually this is the fastest site on the web, but now we get the no internet error. Even though the Wi-Fi icon in the corner still looks connected, the path to the outside world is completely severed. Thanks for hanging out in the lab today. If this helped you understand network security a little better, don't forget to like and subscribe for more.